Welcome to qnawire.
Hi, in the given problem, the expression for magnetic flux linked through a coil is given as 2.00 e raised to the power minus 3 t into sine of 120 pi t. This is the expression for the magnetic flux linked through the coil. So, expression for EMF induced using Faraday's laws of electromagnetic induction will be given by time derivative of this magnetic flux, which is itself as a function of time. So, here it will become the derivative of this function, which is the product of two variables. So, to differentiate it, you will have to apply the product rule, in which first of all, we consider this e raised to the power minus 3t as a constant, and we will differentiate sine of 120 pi t. And then we will consider this sine 120 pi t as a constant, and we will differentiate e raised to the power minus 3t. In whole of this process, 2.00 will remain as constant, common. So now, first of all, we consider this e raised to the power minus 3t as a constant, and the differentiation of this sign will be cosine, cos 120 pi t. After that, the differentiation of this substitute, which is 120 pi t, its differentiation with respect to time will come out to be 120 into pi. Plus, now we have to consider this sine 120 pi t as a constant. So this is sine 120 pi t being used as a constant. So differentiation of e raised to the power minus 3t will be as it is, and then differentiation of this power minus 3t will be minus 3 only. So now if we rearrange these terms, e raised to the power minus 3t can be taken as a common out. So it will become 2.00 into e raised to the power minus 3 t bracket 100 pi into cos 120 pi t, and then minus 3 sine 120 pi t again. So this is the expression for the EMF induced. Now we have to find the value of current passing through the coil at various times. And for this, the resistance of the coil has been given as 5.00 ohm. So in the first part of the problem, we have to find the current induced at a time of 0 seconds. So first of all, we will obtain an expression for the current using Ohm's law. This will be given as epsilon by R. So here it becomes 2.00 e raised to the power minus 3t divided by 5, 120 pi cos 120 pi t minus 3 sine 120 pi t. So when the time is 0, the value of current will come out to be here 2 by 5 becomes 0.4 e raised to the power minus 0 as the time is 0, then 120 pi cos 0 if we put the time 0, and then minus 3 sine 0. And we know sine 0 is 0 while cos 0 is 1. So we get here, this is 0.4 for e raised to the power minus 0. This is 1. This is 120 pi into 1 ampere. This is the current, the value of current. So when we calculate all these values, the current at a time 0 comes out to be minus 150.7 milliamps. ampere. This is the value of current in the first case. And as this magnetic field is upward and it is increasing with the time. So as the reason for the EMF induced is outward increasing magnetic flux, outward increasing magnetic flux. So its opposition will be, as per Lenz's law, inward increasing magnetic flux. And we know magnetic field enters only into the south pole. So the direction of current in the coil will be clockwise. Now, in the second part of the problem, the time has been given as 2.17 into 10 raised to the power minus 2 seconds. So now the value of this current will come out to be, if we put the value of this time here in this expression, the expression used will be the same. In this same expression, when we put the value of time, then the current, the value of this current will come out to be minus 139 milliampere. And as the direction, as the sign of the current is again negative, so the direction still will be clockwise. Then finally, in the third part of the problem, when the time is given as 3 seconds, now putting the value of this time as 3 seconds in the first equation again, the value of current will come out to be minus 0.116 milliampere. Again, it is having a negative sign. So again, the direction of the current induced will be clockwise. Thank you.